Good day, this is the Professor, CBMD PhD, and today's Monday, June 12th, 2023. It is 5:42 and 5 seconds, p.m. Eastern Daylight Time, and today's research, neutron beam. So let's hop to it here. World's strongest and purest neutron beam, improved, date February 13th, 2012. Source, Technicia University. The world's strongest neutron beam is produced in a scientific instrument at the Research Neutron Source, FRM, at the Technician University. As during the long maintenance break in 2011, the scientists improved the instrument PGAA to achieve the best ratio between usable neutrons and noisy background radiation worldwide. The scientific investigators and researchers say it is now possible to determine the elementary composition of even the smallest samples in the milligram range. Neutrons in the PGAA instrument activate the atoms of samples for which the precise composition is to be determined. The methodology is so extremely accurate that it is even possible to determine which mine delivered the one used in a given antique coin. The PGAA generates up to 60 billion neutrons per square millimeter per second. That is an absolute world record among the scientific instruments of all research neutron sources. Other instruments produce only around half as many neutrons that require this high flux for small samples. For example, the researchers say at the PGAA, these are samples of around 1 milligram. They already had the highest neutron flux, but also high levels of background radiation. That refers to radiation which derives not directly from the sample, but rather from scattered neutrons, which interfere with the measurements. The scientific researchers say a low level of background radiation is a prerequisite for examining small samples that react only very weakly to neutrons. The team used a long maintenance break at the FRM in 2011 to improve and reconfigure the shielding of the instrument in such a way that the distracting background radiation is reduced to merely 1/10 of its prior value. The PGAA instrument is used primarily in the analysis of the elementary composition of objects. The measurement device can detect a single atom among 1 million other atoms. This made it possible, for example, to detect tiniest traces of harmful substances captured by an air filter. A magnetic meteorite sample weighing less than 1 milligram was also analyzed. The results of the analysis helped classify the meteorite in this way. A theory making a meteorite impact in North America around 13,000 years ago, responsible for the extinction of the mammoths, could be verified. And this is the Professor of Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.